Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Hello Mustafa, so thanks for these 2020 AS AQA paper 2 questions. So let's have a look at this one. So figure 4 shows a circuit used by students to determine the internal EMF and internal resistance of a cell. Cell is connected to a switch, fixed resistor, blah blah blah. Okay, so readings of V and I are taken as the resistance of the variable resistor is changed from 0 to a maximum value. So you'd have done this practical. It's really straightforward. Usually it looks as simple as this. So there's your variable resistor, and the job of the variable resistor is simply to change values of V and I. So you can plot a graph, and what graph did you plot? Remember, it's this one. Okay, so V is equal to minus IR plus E. Okay, so the gradient of that minus R, and this thing here, E. Right. Now, the question here, well, this one has got an extra resistor in there. So the question is why? Well, when you have the resistance of the variable resistor really low, because you want low voltages for your graph, the current is going to be really high, such that the current, extra current in the circuit could cause to overheat. That goes back into power supply, causes to short circuit, and so on. So any words to that effect. So to limit the size of the current, to prevent overheating. Okay, so words to that effect. So then let's move on. So here's your graph. So figure 5 is a graph. So they put the error bars on there. All right, so the error bars on here would be the systematic error, or the plus or minus half the resolution of the digital display. So determine the magnitude of the minimum gradient of a line that passes through all the error bars. So it's a line of best fit, where it's the worst acceptable, or the one with the minimum gradient. Minimum gradient means the shallowest, and it's got to go through everything. Okay, when I say everything, I mean in terms of the error bar. So if I just start you off, obviously you've got a ruler. So if I drew that, that is not acceptable because I haven't gone through this one. Okay, so therefore I'm just going to adjust this. Obviously you use your ruler, and then so that will, this probably is not far off actually. Yeah, still missed it. So I'm trying to get the extreme, this one, and the tip of this one. So just going to keep moving it. You've got to be as precise as possible, of course. So it's hard to see this one. So that is okay here, and I'll probably try and get it a bit higher here. Okay, so and they're probably looking, yeah, that's not that. So that would be the shallowest thing I could probably draw and still go through everything. You're probably thinking, well, when you use this one, it's, if I did that one, probably get it shallower, okay. But maybe not. So so let's have a look. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and then yeah, I think that's about right. So probably trying to be 250, but I don't think I need to. So, and don't forget, what can I work out from here? So there's the EMF, and the gradient of this is going to give me the internal resistance. Right, so there you go. So the maximum gradient of a line passing through all the error bars is minus 1.3. Determine using Gmax and Gmin the internal resistance of the cell. Okay, so they're giving me the maximum gradient. Let's look at the minimum gradient. So now you've got the range. So you just have to, now the actual internal resistance will be somewhere in between those. So if you've got both of these, that was the max and that was the min, then it's somewhere in between, is it? It's the average of the two. Okay, So we've got to work out the gradient here. So if I zoom in, let's see. So let's pick 2 points, at least 50% of the line. And we're going to find 2 nice points on the graph, maybe this point here, 0.3, 1.02. And let's pick another one a bit further up. So let's pick this one here. So 0.55. And this is 0.76. So just work out the gradient of that. So in this case, 0.55 minus 0.30 over 1.02 minus 0.76. And don't forget it is negative, of course. So punch that into your calculator. So that gives me 0.96. Obviously there's negative there. Now, what's it asking? Let's see. So work out the average of those. So, okay, so 1.3 plus 0.96 over 2. So plus 1.3 divided by 2. So that gives me 1.1 ohms, because it is internal resistance. Okay, so the line of best fit passes through the points 0.94, 0.37, determine the EMF of the cell. So what we got, E is equal to V plus IR. You just worked out R to be 1.1. There's your, which one's which actually? 0.94, 0.37. So 0.94 is the current. 0.94, 0.37, yeah. So 0.94 is the current, and that's the voltage. So we just got to put these numbers in. Okay, so you've got 0.37 plus 0.94 times 1.1. So put it in your calculator, I get 1.4 volts. Okay, so that's how we'd have done that question.